Okay, so that's the topic I'm going to be discussing today, and the focus of our company is actually stair climbing service robots. So aptly enough, that's the name of the slide. Now, here's a breakdown of what I plan to talk about, and I only realized after I put it together that it looks exactly like the Jeopardy categories. So I didn't mean it to be like that. But I'll give you a brief introduction to myself and quantum robotic systems, about our history. Talk about our development history, because it's kind of taken a circuitous route, mostly because of the pandemic. And I'll explain what I mean by that. I'll talk more about our robotic stair climbing assistant, or Rosa. You saw a picture of her at the opening. And that leads into the discussion of our newest robot, QB, a multifunction service robot. And I'm going to take advantage of the captive audience to do a shameless plug for our ongoing Kickstarter campaign around QB. Hope no one minds. And then open the floor for some questions. Okay, so first, introduction to what we're about, what I'm about. We're a small startup founded in 2016, and we make robotic devices. And our primary focus is on stair climbing robots. And I'll explain a little bit more about what I mean by that. You see this as an array of devices that we've made, and I'll explain them each in turn. My name is Frank Naccarato, as you said. Here I am, looking extremely comfortable during a publicity shoot. I don't know why I selected this picture, but for comedic effect. My background is in aerospace engineering, and I actually did my undergrad in engineering science, the aerospace option at the University of Toronto, and I did my graduate work at the Institute for Aerospace Studies. It didn't look like this when I went there, unfortunately. It looked more warehousey, but they've since renovated. My graduate work was in the area of space robotics, and that lets me put up this cool slide because early on in my career, I was able to participate in a couple of projects related to the International Space Station, Canadarm2, and the Space to Ground Antenna Group. And I'm still waiting for the call that says that your software has failed and it's causing all sorts of havoc on the ISS, but luckily that hasn't happened yet. We were able to take some of the technology that we developed for under the umbrella of the Canadarm program and spin it off into in this case, it's a clinical lab robot that automates a process for microbiology labs. The first of its kind, first time this process was automated in this way. And this was actually my foray into product development. I quarterbacked the development of this unit. And after spending some time in the consulting wilderness, I had an idea for a stair climbing robot. And this is actually how I envisioned it. I put together this little video. This is actually one of our proof of concept. But imagine a robot that actually greets you at the door, takes your stuff anywhere you want, including upstairs. So here it is taking some laundry upstairs for you. So on that idea, the company was founded. So a little bit about our development history, going from that initial idea. Again, our focus is on stair climbing service robots, and that's really there are two pieces to that equation. There's the stair climbing part and the service robotics part. Our initial focus was on solving the problem of how do you climb stairs in a novel way to keep the payload level and do it in a way that is basically mechanical, the simplest possible way that you can climb a set of stairs. So that was the challenge we set for ourselves. And Our first proof of concept, here it is, STEPI, is what you saw in the initial video. So this was to prove the concept of the stair climbing mechanism. We partnered with George Brown College here in Toronto, and they have an excellent Office of Research and Innovation, and we've gotten together with them on a number of cases to develop prototypes. So here's the development of the STEPI unit. This is the first time it was actually turned on, the first time it was tested. So it's literally taking its first steps in this video. And this involved some third-year college students who did the machining and the integration. So yeah, so this is a successful proof of concept of how our mechanism works. And we took that and we've since patented it around the world. So our stair climbing mechanism is now the basis for a series of patents. The real challenge here is when you're trying to develop a service robot that can potentially be used in someone's home, you're faced with a competing set of requirements, and they don't overlap necessarily. It has to be a capable robot. It has to do things that are useful, so it has to be autonomous. But at the same time, it has to be small, compact, easy to use, and most of all, it has to be affordable. The price point is a big hurdle. If you price it out of range of most homeowners, that market is shut off to you. So at first, when we looked at this, and we thought, well, it's a really hard nut to crack. What is our minimum viable product after we develop this mechanism? So we decided to focus on the stair climbing part, not the robotics part. So we put the robot aside for a while and decided to focus on the mechanism. This is Dolly. This is a stair climbing moving cart. We took the mechanism that we developed in STEPI and scaled it up, and to see how much we can lift and how much we can help people in the delivery industry, in the moving industry, logistics. And I have a video that shows you Dolly is going through her paces. So it's meant to roll like any other cart, except when you get to a set of stairs, it climbs. And it's meant to carry pretty much anything, including a refrigerator in this case. We tested it up to 500 pounds. The operator isn't doing any of the lifting or balancing. That's the whole point. The platform stays level all the way up. In fact, in another video, the operator walks away midway through a climb, and the load stays balanced. So we were able to demonstrate that the machine can save a lot of time, a lot of injury, and our primary focus was the moving industry. We showed business cases to a number of large companies, showing that they can cut back on their sizes of their crews by a factor of a third. And it saves a lot of downtime. One of the biggest problems facing the moving industry is labor shortages related to injury, and people not coming back to work because of it's just too tiresome a job. It's just too brutal. You have people who are barely 30 going in for back surgery after working in this. We were all set to go. We had lined up our initial customers in the moving industry. We're about to negotiate shipping units, and then that's happened. The pandemic hit, and basically the bottom fell out of the moving industry. It's really tough to move when you can't get into people's homes. Talking to the president of the Canadian Moving Association, I think they took at the beginning of the pandemic, they took a 40 to 50% hit. So nobody was buying any capital equipment. Nobody was interested in evaluating a new robotic stair climbing cart. So Dolly was put into pause mode. And what do you do when that was what you counted for as your first minimum viable product to launch into the market? Well, you do what everybody else does, and you pivot. We had our robotics work that we had on the back burner, and we quickly moved it to the front burner. So we focused on the other side of that equation, on making a good robot. So along comes our next prototype, which is our robotic stair climbing assistant, or Rosa. We developed Rosa primarily for people who need help navigating their stairs. So you can imagine seniors who want to age in place in their homes longer. They need help navigating stairs, which explains why the air-core stair lifts are so popular. That's one of the primary reasons why people end up leaving their homes, is because they can't negotiate stairs while holding on to things. So, and beyond that, just the convenience factor, if you had something that's somewhat bigger than a Roomba, but that can also carry your stuff up and downstairs, that's what we're aiming for. So we come full circle back to our steppy concept. So in this case, a person is loading her up with laundry, app-driven controller, and it autonomously goes up and down the stairs. Eventually, it'll self-navigate wherever you want it to go. We have a control app in development that lets the machine navigate from room to room, and including paths that include stairs. I think somebody asked, what about going downstairs? Yeah, you're right. You're very perceptive. Going up is easy compared to going down. And one of the things we've done in the last 12 months is focus on that very problem. And so this is it's a sped up video, but it shows Rosa tackling an entire staircase and stopping for a brief moment at the top and then coming down. So this is a continuous shot. It's just sped up, and it's using edge detection sensors and impart its mechanism to re-register itself on the edge of the stairs. So yes, it goes up and it goes down. So we had some fun, and this brings us to why we're on BlogTO and City TV. It was part fun and part R&D. Outdoor stairs are a lot more challenging because they are they wear unevenly. They can have chips out of them. They can have debris on them. So we wanted to challenge ourselves and say, can we climb exterior stairs as well? So we brought the machine out to various outdoor staircases, starting small, and we culminated in a visit to Casa Loma's Baldwin Stairs. I'm not sure if you're familiar with them. It's a set of 110 steps, I believe, right at the base of Casa Loma. And we did it in a series of segments, but she climbed the entire set and descended in one battery charge. And we're trying to stay out of the way of pedestrians while we were doing it. And it was a blistering hot July day that we did this on. But she performed pretty admirably. And then she takes a break when she gets to the top. Our site's higher. Once we completed the Baldwin steps, we wondered what else could we do? And I've always wanted to enter Rosa in the CN Tower Climbs for Charity. I think there are 2 per year. And I think it would be a cool way not only to get some promotional value, but also to raise some money for, I think it's United Way has one, and World Wildlife Federation has the other. So we're going to be in touch with them to see if we can get some sponsorship behind Rosa climbing the CN Tower. So look for that next year, hopefully. This brings us to our latest robot, QB, multifunction service robot. And QB is related to Rosa in the sense that when we designed the Rosa device, it was deliberately segmented into 2 main modules. The climbing module, which is the shell that you see on top, which contains the mechanism that actually climbs the stairs, and then the bottom portion, which is the drive module. It's the actual robotic part, the one that takes the machine from place to place. And we reasoned that it's actually a robot in and of itself. If you don't need to climb stairs, it's a highly useful robot in and of itself. So this is our new nearest to market product because it's derived from Rosa. It's fairly good to go. This is its latest iteration, and I'm going to show you excerpts from our Kickstarter video just because it gives you a nice highlight of all the capabilities. So we'd like to tout it as a multi-use robot, a Swiss Army knife of robots, if you will. So we hit the target of those, the orthogonal requirements. It's compact, it's affordable, but it's highly capable. It can do multiple jobs, not just one. It can, and we already mentioned that it forms a central module of Rosa. It's expandable. You can make your own project on top of it, which is ideal for makers or STEM educators. So you get a better sense of its size in this photo. It runs with a control app that lets you program paths. It uses internal odometry to measure its position in the world, but we also have included LiDAR, single point LiDAR sensors, an array of 3, and we could do things like generate point clouds and do SLAM navigation. For a little robot, it has a very large carrying capacity. We've tested it up to 50 pounds. Here it's carrying water that weighs about 30 pounds. And it's delivering from door to door in our facility using the indoor navigation capability. It wouldn't be useful if it couldn't clean floors. So here it is executing pre-programmed floor cleaning patterns. But the advantage here is you can attach whatever your existing mop or Swiffer or whatever this is. We try to identify what that is. We've experimented with wand vacuums. With our tow hitch, you can actually turn any utility cart into a robotic cart. So we've tested it up to a 200-pound load, which is remarkable for a 9-pound robot. This shows some of the team putting the pieces together. And as I said, it's currently on Kickstarter. We're actually, part of our campaign is we're offering packages that we will donate QB units to schools if we get to certain pledge levels. So again, building on the fact that it's an expandable robot that you can customize, and you can also build it from a kit if you want the fun of putting it together. So we think we've kind of found that balance between all those competing requirements in QB. And of course, because QB is a central module within Rosa, Rosa will inherit those when it all comes together. What we're working on now is enhancing the control capability. within the next quarter, we expect to have this functional, where from our app, you can command the robot to go point to point, room to room, destination to destination within your home, within your company, what have you, so that it's a seamless interface for the person using it. If you want the robot to go to the bedroom, press bedroom, and it'll go there. This will require an integration of the single point LiDAR array, but we're doing it in a way that's, I like to call it slam light, in a very thin, lightweight way of surveying its environment. Again, we're using a that's an ESP32 processor that runs the robot. So there's not a lot of computing resources available for it on board. So my shameless plug. We're currently on Kickstarter, and I'm delighted to say we've actually hit our target. So it's real. We're now going to be able to manufacture a small fleet of these, but we're looking for more. It's the campaign is open for another 25 days or so. So that'll give us more opportunity to raise funds to donate more kits to schools, to build more. And this whole thing is to gain the initial traction in the market so that we have products out there being used by our initial early adopters, which is, if anyone's out there, started a company or been involved in a small startup, that's the key milestone to achieve. Getting that is a big deal for us. Here's my contact information if you want to reach me. All our social links are on Linktree, and that's the link there, the URL. It includes our website, the Kickstarter campaign, our Instagram feeds. Everything is on that Linktree list. Okay. So I guess open the floor for some Q&A. Thanks very much, everybody.
I had a question for you. You mentioned you're kind of developing a little mobile app. Is there any opportunity for kind of like a voice command kind of thing, where you're kind of like, hey,
that's the dream.
Go down the stairs and
hooking into the Google Home or Alexa API is certainly doable. I think it's that all the hooks are available to developers, and people have done it. Actually at George Brown, their building automation department has experimented with this as well. So hooking it into our system conceivably is not, I don't see any hurdles to there. It's just doing it, and it's on our radar. It's just not going to be in the initial release. I mean, we're going to pace ourselves, but the answer is yes, we can certainly do that.
John has asked, what about stairs that are not straight up? Like, are you talking spiral stairs there, I think, John?
I'll assume yes.
What are your thoughts on that there?
Yes, because the robot, and both the robot and Dolly have this capability. You advance until you hit the nose of the next stair, and it'll rotate the robot just slightly. And we've experimented up to 45 degrees, both going up and down. So we can navigate the stairs, and since each stair is treated independently of all other ones, they can be of different heights. So we can climb stairs that range from, well, right now 0. We can actually walk on the floor using its stair climbing mechanism, to 9 inches. So anything between 0 and 9 inches, but generally between 3 and 8.5 is the sweet spot where there are no major hiccups. So it is adaptable to different stair heights, and it is adaptable to curving staircases.
Yeah, Ali, great to see you again, mate. Ali has asked. He said, "Great talk, thanks so much. I can see how challenging it could be using single point LiDAR, especially when dynamic environments and odometry wheel slips. Is there any plan to upgrade the PC and use cameras in the future?
We've just an over like a 10,000 foot view of the assumptions that we make. We take the opposite view. We don't start with the assumption that our environment is completely unknown and completely uncertain. We assume there is some structure, so that there are alleyways, there are pathways that the robot can follow, and there might be occasional obstructions, or most importantly, the odometry causes the robot to drift. If you're only relying on internal gyros or encoders, there invariably is going to be an accumulated error. So as you cycle through multiple paths, the robot will drift. And that's the principal concern that we want to overcome using LiDAR sensors. We have to re-reference ourselves relative to walls or any other fixed landmarks. But we assume that your environment is not completely chaotic. That allows us to simplify the problem. Will we eventually get to a vision-based system? Yes. We've discussed integrating, for example, a Pixie 2 camera. I'm not sure if they're small little Arduino-based or Raspberry Pi-based cameras, and they come with some built-in capabilities that are quite advanced, like line following is built in, some object recognition is built in. So, and our plan is to include an interface in our expansion port in the next version that will let you plug in a Pixie camera. So whether you develop it or we develop it, you'll have the interface that will let you do that.
Nice one. Yeah, thanks for that question, Ali. It's certainly, it looks like it's on the horizon there. We have a question from John. John has asked, what's the autonomy for every charge? Does it go to its recharge station automatically?
We started with that plan, and we actually have abandoned it in favor of swappable batteries, like you find in a power tool. Right now, our plan is to ship each robot with a charger and 2 batteries, and it'll have a battery port like your power drill has. And right now, we're using Milwaukee batteries, so they're the same form factor as a Milwaukee battery. And rather than having the machine having to charge and basically be unusable while it charges up, you'll have one battery in a charger, one battery in the robot, swap them, and you'll essentially have continuous operation that way.